Okay, so good day everyone. So for today, we're gonna discuss another type of variation. So you already know the relationship where one variable varies directly or inversely with another variable. So now you will look at the relationship where one variable varies directly with two or more other variables, but does not vary inversely with another variable. So we're gonna have joint variation. So in this discussion, you're gonna know about define joint variation. Second one is to translate statements that describe relationship in which a quantity varies jointly as two other quantities to a mathematical equation. And third one is we have to solve problems involving joint variation. So let's have the definition of joint variation. So let x, y, and z denote three quantities. Y varies jointly as x and z if there is some positive constant k such that we're going to have again this formula y is equal to kxz where the number k is the constant of variation. Again, the formula that we're going to be using is y is equal to kxz where the number k again is the constant of variation. For you to further understand this, so let's have an example. So example number one. So the volume of a right cylinder varies jointly with the square of its radius and its height. When the radius is 2 centimeter and the height is 6 centimeter, the volume is 75.36 cubic centimeter. So we have here some questions. So the first one is what is the constant of variation? So let's write let's find out what will be the constant of variation. So first we can draw what is the given in the problem. So it says here that it is a right cylinder. So we can draw here a right cylinder. So let's assume that my drawing is perfect. There you go. So let's assume that this is a perfect right cylinder. There you are. So it says here that the radius is 2 centimeter and the height is 6 centimeter. So given this, the volume would be 75.36 cubic centimeter. So the first question is, what is the constant of variation? So we are looking for what is the constant of variation. So how are we going to look for the constant of variation? So let's write an equation first. So volume varies jointly. So let's write V. Volume varies jointly with the square of the radius and the height. So we have K radius. Let's use R. The square of the radius and the height. So by means of this equation, we can now look for the value of k, which is the constant of our variation. So what are we going to do is we have to substitute the value of each term that we already know. So we have here the volume. So it's 75.36 is equal to k. That's what we are looking for. The radius is 2, so you put squared and the height would be 6. So after this, what are you going to be doing is you're going to solve or simplify this equation. So you have 75.36 is equal to 2 squared, that is 4 times 6, that would be 24 k. So for you to obtain the value of k, what are you going to be doing is you are to divide both sides by 24. So you have 75.36 over 24 is equal to k. So um when you divide this one using your calculator, you're gonna be having 3.14 is equal to k. Okay, that's the value of our constant. The second question is we have to write the equation of variation. Okay, we have to write the equation of variation. So using the same given or using the same equation a while ago, so let's write the equation of variation. So we'll be having v is equal to 3.14 r squared h. Therefore, this would be the equation of variation. Alright, so this is the equation of variation since 3.14, okay, since the value of pi is equal to 3.14, and in order for us to find the volume of a cylinder, so let's have volume of a cylinder, we have to use the formula V is equal to pi r squared times height. Alright, so this is just the same with V is equal to 3.14 r squared height. Okay, so next one, okay, we have another question here is we have to find the volume if r is equal to 3 and the height is equal to 5. So knowing that our equation of variation is V is equal to 3.14 r squared times height. So let's just substitute the value of r and h. So V is equal to 3.14 r squared. So that would be 3 squared times 5. So V is equal to 3.14 or 3 squared. That would be 9 times 5. That would be 45. Again, when you plug it into your calculator, so V is equal to 3.14 times 45, you'll be having 141. Okay, that's 141.3 cubic centimeter. Okay, so therefore, if Y is equal to 3 and H is equal to 5, therefore, the volume would be 141.3 cubic centimeter. So when writing again, do not forget to have the label. Alright, so let's proceed with example number 2. So in example number 2, find an equation of variation in which y varies jointly as x and z, and y is equal to 45 when x is equal to 18 and z is equal to 10. Find y when x is 20 and z is equal to 30. So let's find first the value of k. So let's substitute the given value. So we have 45 is equal to k times 18 times 10. So we have 45 is equal to k times 18. 18 times 10, that would be 180. So you have 180k. And divide both sides by 45. By 180 rather. By 180. So this will be cancelled out already. So you have 45 over 180 is equal to k. So you may simplify it. So you have 1/4 is equal to k. So having the value of k, let's write the equation of variation. So again, the formula for the formula that we're going to use if we're having joint variation is y is equal to kxz. So we obtained the value of k already, so we can have y is equal to 1/4 xz. Next is we have to find the value of y when x is equal to 20 and z is equal to 30. So you have y is equal to 1/4, x is 20, and z is 30. So plug it into your calculator. So 20 times 30. So that would be equal to 600. So you have 1/4 times 600. So if you multiply this and plug it into your calculator, you're gonna have y is equal to 150. So the value of y is equal to 150 when x is equal to 20 and z is equal to 30. Alright, so next one. So let's have example number 3, and I guess this would be the last example for this discussion. So the volume of a right circular cone, again, circular cone, varies jointly with the square of its radius and its height. So an ice cream cone is 12 centimeter high with a radius of 3 centimeter and has a volume of 113.04 cubic centimeter. If the radius of this cone is decreased by 1/2 centimeter, how much will its volume decrease? So let us understand the problem first. So let V the volume of the right circular cone. So let V, this would be the volume. Okay, next would be the R. R would be the radius of the base. And H would be the height. So V varies jointly as R and H. So let's write the equation. The equation would be V is equal to KR squared times H. Okay, and then after this, let's substitute the given values. So we have the volume already, that's 113.04. Okay, 04 cubic centimeter, wherein K is still missing and R is 3. Okay, and the height is 12. Okay, and then what are we gonna do is we have to plug it in or simplify this first. So we have 113.04 is equal to 3 squared. That would be 9 times 12. That will be equal to 108K. And then we have to divide both sides by 108. Okay, and then when we divide this one, the value of our K would be 1.047. That would be the value of our K. So having this, okay, having the value of K, we can now write the equation of variation by simply substituting the value of K in our equation. So V is equal to 1.047 R squared H. And then after this, we have to solve for the equation. So what would be the value of the volume when the radius is decreased by 1/2? Okay, so it would be decreased by 1/2, meaning you have 3 minus 0.5 or 3 minus 1/2. That would be equal to 2.5. So let's just substitute the unknown value. So 1.047. Your R would be 2.5 already because 3 less than 1/2, that would be 2.5. Okay, then do not forget the squared, and H would be the same. Okay, that would still be the same. So next, so you may plug it into your calculator. So when you plug it into your calculator, the value would be 78.525 cubic centimeter. Okay, so remember, just plug it in right to your calculator. So you type 1.047 times 2.5 squared. Do not forget to put parentheses on it and then times 12. Okay, so the volume of the cone is decreased by how many? When you subtract 113.04 to 7, you subtract 78.525 from 113.04. It would be decreased by 34.515 cubic centimeters. So since 113.04 minus 78.525, that would be equal to 34.512. All right. So should there be any questions? You may message me. And okay, remember, it's not about being perfect. It's about the effort. So it's by Jillian Michaels. Alright, so thank you so much, everyone. And we're going to see you on our next classes. Bye, everyone. Thank you.